Today we're going to talk about motion. Motion is more complicated than you might think. We have to first determine what our frame of reference is. When I see motion happening, the reason I know that motion is taking place is because my frame behind the object in motion is something that I have assigned as being stationary. So if I see a child walking through the room, I know that that child's moving or walking because the wall behind him is stationary. Now, motion is relative because the wall is moving too. If you consider the fact that it's attached to the earth and the earth is moving, that's what makes motion relative. If you're sitting completely still and you're not moving in your room, you can still have motion. At the subatomic level and your molecular level, you are moving. So motion is relative. What we say then is that motion is determined by a measurable change in position. And what we're going to talk about is distance versus displacement. Now, distance is when we look at a total trip. How far did you travel? How much change in position did you have? Displacement is your end position versus your beginning position. So if you consider a student who lives in building A traveling to the school in building B, and let's say he lives 10 blocks from the school. So every day he walks from building A to building B, and at the end of the day he walks back to building A again. So if we wanted to say, well, how much distance does this child travel? Well, he walks 10 blocks in the morning, and at night or in the afternoon he walks another 10 blocks. So he has a total distance of 20 blocks. But if we want to consider displacement, he started and ended in the same place every day. He started at home and he ended up at home. So he has not been displaced at all. His ending position and his beginning position are the same. So he has a 0 meter or 0 block displacement. Now, if he ended up at the school and never went back home, then his distance and his displacement would match. He started in one place and he ended up in the other. And his total distance was 10 blocks. And his displacement from point A to point B was also 10 blocks. Once we have defined what motion is, then we can start measuring some things about it. And two of the things I want to talk to you about right now is speed and velocity. Now, speed is defined as the amount of distance covered in a given time. Velocity is also the amount of distance covered in a given time, but it includes direction. It's just like displacement. It's not just about how far you went, it's about which way. So if I were to say 10 meters per second, when someone asked me how fast I was riding, I could say that I went 10 meters per second. Well, I have just given them a speed piece of information. But if I said 10 meters per second due north, then I am telling you not only my speed, but my velocity. I'm telling you how fast and in which direction. Now, there are different types of speed. We have average speed, which is the total trip. And what we usually do is we calculate the initial speed and the final speed and add those together and divide by 2. Basically, it's just like averaging your grades. If you have 3 test grades, you wanted to know what your average test grade was, you would add those 3 test grades together and divide by 3. Same thing here. You just take your average number of speeds and add them together, divide by the number you have. Constant speed is like cruise control. It does not change. So if I say that something is going at a constant speed, I'm saying that for every second that that object is moving, it is changing its distance, changing the amount of distance covered at the same rate. Instantaneous speed is like your speedometer. If you're driving and your mother asks you how fast you're going, you glance down at the speedometer and tell her your speed, or maybe you subtract a few miles per hour. Now, the initial speed is your first speed, and final speed is your last speed. We're going to be using those a lot, but I want to make sure you understand that initial does not always mean 0 or the lowest speed. It's simply the first speed that I look at. It could be 0 if we have started at rest, or it could be the highest speed. If I start looking at a race when the vehicles are traveling around the track and go to the end, the initial speed is that higher speed in the middle of the race. Final speed, again, does not always have to be 0 or the highest value or the lowest value. It is simply the last speed that I look at. Now, our formula for speed says speed or velocity equals distance divided by time. And we're going to measure speed in meters per second, distance in meters, and time in seconds. Now, we can also use kilometers per hour for our speed. Remember, the rule here is that if I have a large unit for distance, I need a large unit for time. So meters per second is a small unit for distance with a small unit for time. Kilometers per hour would be the large unit of distance for the large unit of time. The triangle is your mathematical triangle. We can take this formula and take distance and time, because they're together dividing here. I can put them into the triangle so that they divide here, and then just put velocity in the place that's left over. All right, acceleration is another way of describing the motion of an object. And acceleration, by definition, is the change in velocity in a given time. So it's also a rate value. We're going to have time in the equation. Now, there are two different kinds of acceleration. We have positive acceleration and negative acceleration. Now, in our culture, we're used to using the word acceleration to mean the positive, speeding up. Accelerator is that pedal in your car that you press, to make things go fast. Well, the positive acceleration means to increase. Negative acceleration, notice the word acceleration is still there, means that I am decreasing. Now, what we usually term that is deceleration. We don't take the time to say positive acceleration, negative acceleration. We just say acceleration or deceleration. But please know that the mathematical definition is not just to speed up. It's a change in velocity. It does not say just to increase the velocity. So that means then that there are three ways to change or to create acceleration. I can speed up, of course. I can slow down. But notice I can also change direction. Remember, this word velocity was speed plus direction. So even if my speed stays the same, if I change the direction of the object, there's going to be an acceleration on that object. For a lot of you that might be learning how to drive or have recently learned how to drive, you can have a direct experience of this. If you didn't slow down enough when you went into a turn, you know that your car is going to accelerate in that curve, and you're going to have acceleration even though your speed hasn't changed. So changing that direction causes an acceleration on the object. That's the reason we slow down before we go into a curve. All right. Our formula for acceleration is VF minus VI over T. Now, this VF is your final V, and the VI is your initial V. So notice that it is last minus first. So you want to make sure that you take the last speed and subtract the initial speed from it. Remember, it's not high minus low. It's just going to be last speed minus first speed. So it is possible to get a negative answer here. Especially if I'm decelerating, I should get a negative answer. Time should never be negative, but we're going to have seconds. If we have meters per second up here, time should be in seconds. If we had kilometers per hour, then the time should be in hours. And the acceleration value here, meters per second squared, what that unit is saying is that for every second that I'm accelerating, I'm going to go 10 meters per second faster. So if you think about gravity is 9.8 meters per second squared. What that acceleration means is that for every second something falls, it's going to go 10 meters per second faster, or 9.8 meters per second faster. So this measurement here, this square, is only on the second value. It's not on the meters per second. Now, if I was looking at large units, kilometers per hour, I would describe acceleration as kilometers per hour squared. For every hour I accelerated at this rate, I would go so many kilometers per hour faster.